Hello, everybody. We are back again. This is the Chegg Live Office Hour, and we'll be doing trig and pre-calc. And for the people who haven't been here before, welcome. But if you have been here before, then welcome back. Today, we will go over some of the pre-calculus questions. And I think most of us are going toward the end of the semester period. So we will do just some more like final exam review and things like that. Well, if you're here already, make sure you try this question, which is on the board. We are going to convert the rectangular equation y is equal to x squared to the polar equation. And remember, for polar means that we are going to write r as a function of theta. Right? And then we have these options. So go ahead and give it a try. You have to know the conversion formulas. All right? So go ahead and try that and then leave your answer in the description. Leave your answer in the chat so I know if you are okay with this or not. Okay. So welcome everybody. Hello everybody. And for the people who are here, thank you so much. And let me just wait for some response. Okay. What grade of math is this? For pre-calculus, you could be like a high school 10 or 11th grade, and maybe at a community college, like pre-calculus too. So it kind of depends. Yeah. But this right here, it's like the foundation of calculus. You have to know the trig and also the algebra really well in order to do well in calculus. So go ahead and try these questions first for whoever is here already. So if you're here, thank you guys so much for coming. This is the live office hour brought to you by Chegg. For more info, please scan this QR code right here, and then make sure you follow Chegg's social media, YouTube, Twitch, TikTok, Instagram, all that. This is our last live stream for this semester. All right, so next week, no more, but hopefully in the future, we'll do this again. But today, we will have this going from right now for an hour. So make sure you guys try this question first, and I'm going to solve it in like 20 seconds or so. So for the people who are here, thank you guys so much for coming. Thank you guys so much, and then we will see how to do these questions. Yep. And if you have any questions, please go ahead and put it in the chat. I can see the chat. This is live. So if you have any of your math questions, and make sure you keep it either trig or pre-calc related, then I will be happy to answer them for you. Now, here we're going to convert y is equal to x squared, which is a parabola in the Cartesian equation world, to polar. These are the formulas that you have to know. Firstly, r is equal. Firstly, we have to know that x is equal to r times cosine theta, and then y is equal to r times sine theta. And this is like the same thing on the unit circle, or maybe just like the usual sine is equal to y over r definition. Not necessarily on the unit circle, because on the unit circle, r is equal to 1. Anyways, here we go. Put this in here. This go here, so we have r sine theta is equal to x is r cosine theta, and then we have to square that. And then let's just go ahead and proceed. R sine theta, this is r squared, and this is cosine squared. Now, our goal is to get r by itself like this. We want to write r as a function of theta. This is just like a notation to say that just that. We have r to the first power here, and this is r to the second power here. So let's go ahead and divide both sides by r. That way we can get rid of this r, and then that way we will have one r right here. And remember, we want to isolate the r. So why don't we divide this to both sides? And that's cosine squared theta right here. So that this and that will be gone as well. Now, if you look at this right here, I'm going to write it down as r is equal to sine theta over, we have cosine squared theta. but I don't have that as an option. So this is what we are going to do. I'm going to write the first cosine in red, and then the second cosine in black, because this is like 1 times sine theta. 1 over cosine is secant theta. Next, sine theta over cosine theta, that's tangent theta. Therefore, the answer is D. This is it. So I like this kind of questions a lot because not only you have to know how to work with Cartesian equations and also polar equations, you have to know the conversion formula, but in fact you have to be doing with a lot of trig identity stuff as well, which is one of the most difficult part in trig or pre-calc. Remember, pre-calc is like half college algebra and then half is like trig. Yeah. So let me see how you guys are doing here. How am I doing? I'm doing good. Thank you so much. Let me tell you though, this is our last live stream for this semester, and yeah, so we don't have live stream next week. We will see what will happen in the future in the fall semester. But today we will have this going until 7:45 p.m. So right now it's only like 6:50, so we have another 55 minutes or something like that. Yeah. All right, let me take a look at what you guys have. If you guys have any questions, feel free to drop it in the chat. It can be algebra and trig because that's the foundation of pre-calc. Right? Let me know. Actually, let me do a quick survey. How many of you guys are in high school? If you are in high school, just put HS. So that way I know you are in high school. If you're in college, just put on college. And if you are out of college because you're done, you can just say you graduated or something like that, or after college or something. So let me just do a quick survey. I want to see the demographic of the audience right now. Yeah. All right, I do have some questions prepared for you guys, but if you have questions, feel free to let me know. I'll be happy to answer them for you. Okay, so far we have like 2 high school, 2 college, and 1 graduated, and then another high school. Okay, so high school we're not done yet, right? We still have about another month to go for high school. But for college, many of you guys are taking the final exam like this 2 weeks, or maybe you guys are done already. For my school, our final is in the first week of June, so we still have about like 3 weeks. Middle school, okay, wow, okay, cool. Try convert it to hyperbolic coordinate. I don't know how to. That's an interesting idea. Excuse me. That's an interesting idea, but I do not know if I do not know how to do it. Truth to be told, I do not know how to do it. I don't even know if that's yeah, that's an interesting question though. Yeah. What kind of math are we focusing in pre-calc? I think you're asking what grade, right? In that case, it could be like it depends on the student, but usually either the 10th or the 11th grade. Yeah. Thank you. Thank you. Any advice for linear algebra? Well, unfortunately, right now we are focusing on trig and pre-calc. But I can just tell you real quick though, linear algebra is hard. It's slightly more abstract, and because you have to start to do some proofs and all that stuff. But for this live stream, I will have to keep it within trig and pre-calc. Yeah. All right, let's do a very classic type of question, right? So here, I'm going to tell you, given, let's say we have cosine theta for some angle that you don't know and you don't need to know, all right? Cosine theta is equal to, let's say, 2 over 5. And in fact, based on this right here, there are a lot of different types of questions that could be asked. One really popular type is that I will say cosine theta is this, and sine theta is negative. And we're going to figure out the other things. Question, we can figure out, let's figure out A, B, and C. Let's go ahead and do, all right, let's do this. Why don't we do cosecant theta, and then secant theta, and then cotangent theta? Truth to be told, once you know one, you pretty much know the others. But let's just go ahead and do 3. Usually I like to ask like this kind of questions a lot. All right, this one question that's really easy, and that is secant. Because if you have cosine is 2/5, then secant is just the reciprocal, so we are done for secant. It's just 5/2. You don't really have to do anything else, and then we're done. Now the hard part is, how do we figure out this and that? And then, by the way, what exactly is this doing, right? Yes, you can use a calculator to figure out the angle, but you don't have to. The key right here is to draw a reference triangle based on this right here. So let's have a look. We know that cosine theta is equal to 2/5. You can draw this on the xy plane. In that case, you look at the cosine as x over r. X is the adjacent side, r is the hypotenuse. R is always positive, x could be negative, but this right here we have positive too. So let's have a look. We have to have positive x, so that means we're either in the first quadrant or the second quadrant. But, I'm sorry, I said it wrong. First quadrant or the fourth quadrant, because it goes like 1, 2, 3, 4. So this is the fourth quadrant. Here, sine theta is less than 0. That means we have negative y value. So we are below the x-axis. So this right here means we're in quadrant 4. We're in quadrant 4. So we are looking at this part right here, and let's go ahead and draw our reference triangle. Here I have 2 for the x. I'm just going to put it down, let's say somewhere here. This is 2. And then the r is the hypotenuse. It's always positive. I'm going to put it down like this, somewhat like that. And then we will have to figure out the opposite. Once we have this triangle, we're pretty much done. And this is how you do it. To figure out the other side, just open the square root. Take the hypotenuse, which is 5, and then square that, and then minus the other side squared. Work that out. That's 25 minus 4, which is 21. So this right here is 21. But here's a small detail. What's wrong with this right here on my picture? What's wrong with this right here? We can also use cosine squared plus sine squared. We can also do that. I usually like to just show you guys the special, the reference triangle, because once we have this, the rest is pretty much automatic. Oh, so you said, hello, Black and Red Pen. I enjoy watching my 100 problem video. Thank you so much. It should be correct, because this is down below the, right? So it should have been a negative right here. Negative, right? It should have been negative. That's why I purposely pause it to make sure you guys are okay with this. Now we can look at this reference triangle and just do the usual business. For quick example, cosecant is hypotenuse over opposite. So we have 5 over negative square root of 21. And I'm not going to rationalize the denominator. I'll just keep it like that. And then for cotangent, it is adjacent over opposite, which is 2 over negative square root of 21. And then we are done. Just like that. Oh yeah, by the way, the AP Calculus test was today, right? Let me know how you guys did. If you did take the AP Calculus test in the morning. Yeah, we're toward the end of the semester, so yeah, final exam time, or maybe you're just kind of waiting for graduation, or maybe you have already graduated, depending on where you're attending school. But again, if you have questions, feel free to let me know, especially if you're preparing for your final exam. Just guy in the chat, welcome, Kenneth. Wait, for that question, which angle are we reviewing for its theta? Okay, sorry. For cosine theta equals 2/5, and then we say theta, as we discussed earlier, in quadrant 4, and then we draw the reference triangle here, right? Technically, it's this angle here, but well, technically it's like this. It can be like this, or it can be like this. They're coterminal. Doesn't really matter, but you should be really looking at this right here. You can take this as a reference angle. Yeah, you can take this as a reference angle. Either way is okay though, because they're coterminal. So that's why I was saying, look at this right here, and then this will be the opposite side. This is the adjacent side, and this is the hypotenuse. But the opposite will be negative because it's down below the x-axis. Could you do some advanced algebra? Do you have any equations for me? If you have, let me know. Where was my previous live stream? It was on checks.com. It was on their website. You have to sign in for that. Yeah, and I did make a post. Hopefully you guys all see it last time, that the live stream last week was on checks.com only. So that's why you have to go there. But I do want to tell you guys that this is our last live stream from Chegg for this semester. I'm not sure if we'll be doing this in the future. If we do, I will let you guys know, of course. Can you do composition of trig function and the inverse? Okay, excellent question. Let's do one straightforward one, and the other one, let's do some with double angle identity on top. So let's do this one. Yeah, let's do sine of, let's do inverse secant. That should be really interesting. Well, actually, no, let's make it slightly more interesting. Instead of x, let's put it as x/3. How's that? Yeah, I think this is what you want, right? And let's go get it. Firstly, whenever you have an inverse function, it actually represents an angle. So I can start off by saying that theta being the angle, which is now inverse secant of x/3. And then if we apply the original secant to both sides, this tells us secant theta equals x/3. And I'll just do the triangle method because I think it's so wonderful. For secant, it's hypotenuse over adjacent. So this is the HYP over ADJ. And then draw the triangle. Here, I'm going to put a... Oh, that doesn't look like a triangle. That looks like a little hill that is like bumping, going up. No, let me try one more time. Hopefully better. Something like this. I usually just tell you guys to put the triangle here and then the angle theta here, just for consistency purpose. Hypotenuse is this right here, x. Adjacent is this right here, 3. For the other side, do the same thing. First, open the square root. You take the hypotenuse, square that, minus the other side, square. If the unknowns on the hypotenuse, you will have to add them up. But here, hypotenuse squared minus the other side squared. And this right here is just square root of x squared minus 9. Now, sine of this, which is really sine of theta, we can just pick that up from this triangle, and that is just going to be opposite over hypotenuse. So the answer for this is square root of x squared minus 9 over x. And then we're done. Yep, the AP Cal exam was today at 8 a.m. Let me know how you guys did though if you took the AP test. Oh, How about the AP Precalculus test? When is that going to be? Would you guys say that the AP program or the IB program is better? I actually have never done IB program or like I don't have experience with IB program, so I don't know. But like for the people in the chat, if you have experience with both, maybe you have tutored people in both areas, or maybe you have been in the AP class before and also IB class before. Feel free to share your experience so we can learn from each other. Are integrals hard? Yes, they are. Okay. Oh yeah. So you did give me a question like are cosine of arctangent of 2/5. Okay, let's do that. I'll do that real quick right here. So if you want to do cosine of arctangent of 2/5, we can do the same thing. Arctangent is going to be the angle theta. So this right here tells us if you have tangent theta, that will give us 2/5. And then just draw the triangle here, 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 right angle theta, opposite over adjacent. And then for the hypotenuse, this time, we're going to open the square root, and then we are going to add the other side's square. So I'll just put 2 square and then 5 square. So this is really just 4 plus 25, so that's square root of 29. And then we're doing cosine. Cosine is adjacent over this, which is 5 over square root of 29. And then we're done. Just like that. Thank you so much for saving your Cal 2 grade. Oh, thank you so much for telling me, Lucas. Yeah, let me know when the AP Precalculus test is. Did that happen already last week or is it about to happen? I know this is like the AP exam season, so let me know. Is there anybody who's like taking like 5 AP classes in the chat? If so, let me know too. All right, so if you have any math questions, feel free to let me know. Okay, I'm going to talk about the notation real quick for the arctangent. So this right here is the notation. I would say this is the original. So we have like sine, cosine, tangent, right? Let's just use them as examples. So we have the original sine function, let's say sine of x, and then we have the cosine of x, and then we have the tangent of x, right? These are the original. And then next we have the inverse. For the inverse, we're just going to put a -1 right here, like this. And that's actually the notation that you will see on a calculator too. So either if you don't like it, which many people don't because of the -1 notation, but just try to get used to it. And of course, we have inverse cosine and also inverse tangent. However, since the -1 notation is confusing sometimes, we will also write this. This is the alternative notation. Alternative notation. We can also write it as arc sine of x. Arc sine of x. And then this is arc cosine, and this is arc tangent. Just like this. And one thing that you have to know is the warning. Let me just put this down right here. I don't think this is. Let me see if I have another marker here. Okay, this one doesn't work. Okay, I'm just going to use. my regular colors. So here is the warning. So be super careful right now. Here, when you have sine -1 like this is not the same as 1 over sine x. The -1 doesn't mean the 1 over. However, if you do want to say this right here, you will have to write sine x and then raise to a -1. This does mean 1 over, so that's a check mark. Now, this is the confusing part, right? Because in the past, you might have encountered a situation that if you have sine x raised to the second power instead, you could just write this with the 2 right here. And that's also correct. And if you have like third power or whatnot, you can put it here. That's fine. However, that rule does not apply for when you have -1. This is not the same as that. That's why we have different notations for it. Right? So that should take care of the notation. Yeah, many of us know that the -1 right here is like the reciprocal. In fact, it does have some meaning with a -1. That's the, it depends on how to look at it. For example, if you have, let's say, let me just draw this right here real quick. Let's say if you have, let's say, 5 to the -1. This does mean 1 over 5, it's the reciprocal. If you have x to the -1, this also means 1 over x. This is also correct. But not true for functions though. If you have f with a -1, this in general is not the same as 1 over f for functions. Yeah. The reason I said that the -1 and the inverse does kind of have some similarity is that, here, check this out. If I do 5 times 5 to the -1, I get 1. Because I'm just doing 5 times 1 over 5. So that's that. Here, why do we use the -1 notation? Here, you cannot just say f times f inverse. This does not give you 1 in general, so this is no. However, if today you do this, f of f inverse, let's have an input. This is okay, assuming in domain of whatever that is. Right? This is true if x is in the domain of the inverse of that. So you can see that you cancel it out. You get back to like the input, which is like the original. So it's kind of like cancellations like this. When you cancel them, you have that the 1. So I think that's the reason why we have the negative. But for functions, it's mainly about function composition, not about function multiplication. So that's the reason I think why. As I said, though, for now, at least know that these notations are the inverse. Do not do this right here. Yeah, I know it's pretty crazy why this is okay, but not with the negative ones. There are exceptions for that. Can you go over powers of trig functions? What do you mean by that? Do you have a specific example? Will you please any tips for partial fraction decomposition? Partial fraction decomposition, are you talking about the ones in pre-calc or in calculus? Because that's a calculus topic. Many of you guys might just encounter that in calculus. We can treat that as an algebra question, so we can do the algebra part, but we are not going to get into the integral part. So I'll do that real quick, right? Let's do the partial fractions first, all right? Let's do partial fraction first, and then I'll take care of the powers of trig functions later on. So partial fraction decomposition, right? And I'm just going to abbreviate that as PFD, not PDF, PFD. I just wanted to write it better for you guys. I didn't write it wrong. PFD. There are several cases that you have to know. Let's talk about the setup. Right? Here are the setups. Case 1. When you have linear factors on the bottom. So let's see. If you have something on the top, and let's say you have just an x plus 1 times x plus 2. I'm going to keep it simple. Here's one rule though. The degree on the top has to be lower than the degree on the bottom. On the bottom, the degree is 2. So on the top, the degree has to be less than 2. If the degree on the top and bottom are equal, you have to do polynomial long division so that can reduce the degree. Anyways, here the first fraction will have x plus 1 on the bottom, and the second fraction will have x plus 2 on the bottom. Now, when you have a linear, then top is just going to be a constant. It's going to be 1 degree less than the bottom. So the top is just a constant. We put it as a. For this one, same thing, but it will be a different constant most likely. Now, here's the deal. As long as the degree on the top, that polynomial, is less than 2, this will be your setup. It doesn't matter what it is. Right? It doesn't matter what it is. I could have, let's say, 3x plus 7. I set it like this. I could have 13x minus 7. I set it like this. I could have 13x minus 75. I will set it like this. Okay? And let's focus on the setup first. I'm just going to erase this again. And I would just like to focus on telling you guys the degree on the top has to be less than 2. If you have another factor on the bottom, then the degree on the top has to be less than 3. Then you can do that. Now, the second case is when you have some quadratic factors that are not reducible. Here, let's say we have this x plus 1 times x squared plus 2. Now we have a quadratic factor. And this right here, it's not factorable with real numbers. So that's what I mean by irreducible with real numbers. Degree is 1, degree is 2. You add the powers, degree is 3 on the bottom. So the top, as long as the top degree is less than 3, you are going to set it out like this. The first one has x plus 1 on the bottom. The second one has this on the bottom. And I cannot factor this anymore with real numbers, so just keep it. Now, this right here will be a constant on the top. This right here, it has to be 1 degree less. When you have a quadratic, the top will be just a linear. So you set it as bx to the first power and then plus c. So these are the 2 basic ones that you have to know. The third case is like the trickier case. You really just have to know these 3 based on how I present it to you guys. But the third one, I would like to just take a look at the chart to make sure you guys are okay before we move on. Okay, here we go. This is the third one. Okay. The third one is when we have a repeating factor. So you're going to pay attention to when you have the power on the outside of the parentheses. Here is an example. If I have x plus 1 to the second power here, let's do it like this with the second power here. And then I will just keep this x squared. No, I will just keep it. Oh, no, I will just keep it x squared plus 2. Okay. Now let's see. The degree here is 2. The degree here is 2. Together, the degree is 4. So you have to make sure the degree on the top is less than 4. Now, this means we really have x plus 1 times x plus 1. Would you agree? So this is the repeating factor because x plus 1 is happening twice. So pay close attention to the power on the outside. When you have a repeating case, I like to call this that you have to build up the powers. Starting with the first power, I must have x plus 1 to the first power, and then I must have x plus 1 to the second power. And you can imagine, if I change this to a 3, that means x plus 1, x plus 1, x plus 1. This is the third power, 2 more altogether is 5. So if the degree on the top is 5, less than 5, here, if this is the third power, I will just have to do another one. I have to build out the power. until whatever that is. Now, when you build out the power, the top stays the same kind. Here, it's a linear, so the top is just constant. And then we are building out the powers, the top will be the same kind. So this will still be a constant. This will still be a constant. All right? Now we still have this, right? So I'm just going to put it right here. We are going to add x squared plus 2. This is the quadratic. On the top, it's going to be a linear. So we're going to do dx plus e, like that. Okay? Now, what if this is also being repeated? Let's say we have x squared plus 2 to the second power. Here we have 3, here this is 4, altogether is 7. So as long as the degree on the top is less than 7, this portion stays the same, but right here, we still have to build out the power as well. We have this to the first power, and then I will have to add x plus 2. So x squared plus 2 on the bottom, and then square, building out the power to whatever that is. And the powers has to be positive whole numbers because we're dealing with polynomials. The top stays the same kind, linear, and you still get linear. So we have fx plus g. You can imagine if you have the third power, you will have to have one more. So this right here, it's like the quickest way for you to remember the setup of the partial fractions decomposition. And I hope this right here helps. If you have any more questions, definitely check out the QR code here and then see what Chegg has to offer for you. All right, and then let me take a look at the power of the trig 1. I'm trying to look for the question that you asked earlier. Okay, sine, cosine squared. Okay, let me see. And of course, the next thing is to solve for A, B, C, D, all the unknown constants. But truth to be told, those will take a very long time. Some of you guys, if you guys did this, if you guys are doing this in pre-calc, which is possible, it's good because in Calc 2, you'll see this again. But right now, I would like to verify that sine x minus sine x times cosine x squared. This right here actually gives us sine x to the third power. So I'm just going to write this down, but I'm not going to touch it. I'm not going to touch it. So let's see how we can do it. From the left, do all the work, and then get to the right. Firstly, sine x, we can factor that out. So we will do that. This right here, factor that out. So sine x divided by sine x, we have 1. So this is 1. Minus, we took this out already. So this right here is cosine x to the second power. This is the second power. We can put a 2 right here as our discussion earlier. So 1 minus cosine squared x. What can we do next? Does this look familiar? It should, because I'll just put a real quick note right here. If we have sine squared x plus cosine squared x, this will give us 1. This is as known as the Pythagorean identity. And of course, if you see the 1 minus, we can just subtract the cosine squared to both sides. So we can see sine squared x is equal to 1 minus cosine squared x. So instead of this, we can replace that with this, put it here. So we get this sine x from the front times all this right here is just sine squared x. Add the powers. This right here is just sine to the third power of x, which is the same as that. If you would like, you could also have put it as sine x to the third power, and then we're done. So put on done, just like this. The reason I didn't box it is because for doing this kind of questions, you have to make sure you show all the steps, so you cannot just put down the answer right here. So yeah, and then sometimes, depending if you have done proofs or not in your math class, you can put a box, share this in, meaning that the proof is done. Or for the people who prefer QED, you can also put on QED. I'm always like the box guy, like this, a box with like maybe 3 or 4 lines. All right, so if you guys have any more questions, feel free to drop them in the chat. Yeah, unfortunately, this is our last live stream for this semester. For the future, just make sure that you stay tuned on my channel, and also make sure you subscribe, and also make sure you check out the QR code right here from Chegg. If there's any more live streams in the future, once you subscribe, once you follow them, I'll let you guys know. So let me see, what do you guys have? BPRP has been a huge inspiration over the years for you. Thank you so much. I'm so happy to hear that. Thank you so much. Are there 2 more weeks after this? I think I told you guys the wrong thing in the past. I told you guys it was going to be at the end of the May, but it's actually at the end of the semester, and this is actually the last one, the last live stream that we have. So I do have a mistake. I apologize for that. Calculus stream, maybe in the future, but this is the last one for this semester. Many of them, the college students, are taking the final exams this week, or maybe next week, or maybe something are done already. You guys can see a lot of the graduation videos online nowadays, right? So that's that. Okay, tangent of x plus pi over 4. What are we doing? Is that solving for x? What's this? Are we trying to prove this? Or are we trying to solve for x? Tangent of x plus pi over 4. And then times tangent of x minus pi over 4. And that is equal to -1. So what are we trying to do? Are we trying to show this as equal to -1, or are we trying to solve for x? I couldn't see you last week because last week's live was on Chegg's website. I did make a post. Hopefully you guys all see it. If not, then just make sure, maybe just because of the YouTube notifications. Yeah, it was on Chegg's channel on their website. So that's why you guys didn't see the live stream last week. And this is the last one that we have for this semester. Okay, so we're going to prove that this is equal to -1. Okay. So this right here looks kind of suspicious. I'm going to kind of turn it, right? Switch it, right? So this, I will just keep it. Tangent x plus pi over 4 times, this is tangent. And I'm going to factor out negative and then switch the subtraction. So we have tangent negative of pi over 4 minus x. All right. So that's pretty good. The reason I did that is because so I can put the negative on the outside, because tangent is an odd function. So far this is the negative from the inside of the tangent to the outside. because again, I'm just saying because tangent is odd, and that means if you have tangent of negative theta, this is negative tangent of theta. So that's the jet. I can put a negative on the outside. So this right here becomes tangent x plus pi over 4. And then this is times tangent of pi over 4 minus x. Now, I'm gonna just use this answer for a little bit because the only way that two things multiplying and you get 1 is one of them has to be the reciprocal of the other, right? This right here. And I'm going to do this. Pi over 4, so I'm just going to make another note. I believe pi over 4 can be looked at as, hold on. Yeah, let me write it down like this. Okay, pi over 2, it's the same as it's the same as 2 pi over 4, which is the same as pi over 4 plus pi over 4. So what I'm going to do is, I'm going to subtract pi over, why did I do this? I don't know, but I'm just going to say pi over 4, it's the same as pi over 2 minus pi over 4. Fair enough? And I'm going to put this for that. Right? Put this for that. Actually, do I just have to do that in the beginning? I know where I'm heading to, but I just want to know which is like a... No, I'll still do this. I don't think it matters. This is negative tangent x plus pi over 4 times tangent. For this right here, I'll write it as pi over 2 minus pi over 4 and then minus x. Right? I know it doesn't erase it. It's not working today, so I have to actually erase it myself. I'm sorry. Now, if you look at this part right here, we can factor out a negative. So this right here is negative tangent of x plus pi over 4 times tangent. I will keep the pi over 2 and factoring out a negative. And this right here will give us both of them being positive when we put them on the inside. So that becomes pi over 4 plus x. And do you guys see it? When you have pi over 2 minus an angle, you'll just get the cofunction, the coversion of whatever this is of the angle. So here is a quick note. I am going to put it right here. Note. For example, if you have tangent, if you have pi over 2 minus an angle theta, well, if you just have the angle theta, together they add up to be pi over 2. So they are complementary angles. This will be the same as the coversion of the tangent, namely cotangent of theta. Same thing. So you have this, which is negative tangent x plus pi over 4. And then all this right here, it's really just cotangent of x plus pi over 4. Well, pi over 4 plus x, doesn't matter. When they multiply, you just get 1. So finally, we just end up with negative 1. And then once again, we're done. So box it, just like that. Some of you guys might even want to try like the angle sum identity, but you didn't have to do that. Yeah, I think this right here, and maybe you could have like skip some steps here and there, but I think this right here can make everything clear for you guys. So that's it. Oh, you could have used tangent of x plus pi over 4 as 1 plus tangent x over 1 minus tangent x. Yeah, I think that will work, and you also change the minus version. So yeah, either way. How do I factor x to the fourth power plus x squared plus 1? Let's do an algebra question. Okay, sure. Let's factor that. X to the fourth power plus x squared plus 1. And if you have entered some questions, if I don't get to it, I'm sorry. And then we're not doing integrations, I'm sorry. And we're just trying to focus on pre-calc or trig. So the goal for this right here is to factor it. Let's think about this a little bit. This is kind of like x squared, yeah? And then we have x squared, and then plus 1. So at least we're making some progress, right? But of course, let's see. We have something square, and the one that's, of course, we can look at this as 1 square, like this. And then we can say multiply by 1. So we have a square plus ab plus b square. Now, let me remind you guys, when we have a square by b, it's a plus 2ab, and then plus b squared. This is the one that we can factor, and then we get a perfect square in the a plus b square. We're almost there. We just need the 2. I cannot just multiply this entire equation by 2, though. We cannot do that. But it's okay for us to just add one more term. Check this out. I'm just going to add 2. No, not just one more. So I'm just going to add x squared. But I cannot just add it. It's okay, though. Just go ahead, subtract it. Then we're really adding 0. So if you add this and that together, we will get x squared plus 2 x squared plus 2 of this, 2x squared times the 1, and then plus 1 squared. And this will fit in here. And then we still have minus x squared. Now, ladies and gentlemen, the first 3 terms can be factored by using that. So we'll do it. So we get the a is x squared, and then the b is the 1. So we have x squared plus 1, like so. And then minus x squared. Have a look. We have a minus. This thing square, this thing square. This is a difference of 2 squares. So once again, we can factor it, right? So let's see if I can just write this down. Here we have the first thing, which is that. So I'll just write this down as the first thing, x squared plus 1 minus the second thing here times x squared plus 1, and then plus the second thing here. A minus b times a plus b, just like that. And then finally, I just want to change the order to the order that we like. Put this here first. So we have x squared minus x plus 1, and then x squared plus x plus 1. And then we're done. Just like that. Okay. Okay. So I think we're okay with this, and then maybe we have some more time for one more question, because right now it's 7:39 already, and yeah, we have about like 5 more minutes. So let me know if you have any other questions. But for the people who are here, thank you guys so much for coming here today. If this is the first time that you're here, thank you for joining us. If you have been here before, thank you so much for coming back. It really means a lot to us. And then again, if you want to stay tuned for the future live streams, make sure you scan the QR code and subscribe to their YouTube channel. And yeah, just sign up for the account. It's free to join. You can also get some updated. Just like last week, our live stream was on Chegg's website. So make sure you just join them, and then let me just see that. When's the calculus live stream? I don't know. Unfortunately, this is going to be our last live stream for this semester. Any future live streams, we'll let you guys know. And again, if you scan the QR code, you can stay informed. You were here since around February. Thank you so much. That really means a lot to me. Thank you. When's calculus stream? I don't know because we are just doing trig and precalc for this. Maybe in the future. If you want to factor x to the fourth power plus 4, you will have to add 4x squared and then subtract 4x squared. And you can try that. So perhaps I'll write this down real quick. Yeah, and then go ahead and add 4x squared and then minus 4x squared. And then these three terms can be factored into a perfect square, and then this is going to be a difference of two squares situation again. So try it and let me know. Greetings from Mexico. Thank you so much for joining us. Yeah, AP exam was this morning, right, for AP Calculus. And let me know about the AP Precalculus. So, okay, I see the question. Inverse tangent of 1 plus inverse tangent of 2 plus inverse tangent of 3 is equal to pi. I don't know if I can do that in like next 3-4 minutes. I'm sorry though. One thing I can do is that reminds me of this right here. 1, 2, right? And then here, this is going to be pi over 4, which is inverse tangent of 1. These are all squares, by the way. And then do another one. This is going to be, well, inverse tangent of 1/2, depending on how to draw the triangle or the squares. And then the third one. So this is the famous 3-squared puzzle. Oh, so if you do want to do the calculus live stream, it's on Thursday from 4:15 to 5:15 p.m. on TikTok, right? So calculus live stream is on Thursday, 4:15 to 5:15 p.m. Pacific time on TikTok. We are not doing integrals today, unfortunately, but the calculus stream is on Thursday from 4:15 to 5:15 Pacific time on TikTok. So make sure you just scan the QR code. You can find all the information that you need right here. Like this is the QR code. Just scan it, or maybe click the link in the description so you can see the homepage of Chegg, or just go to chegg.com. And we have about like 2 more minutes. So I just want to read through your questions. Yeah. Thank you guys so much for coming here today. And it has been fun. It has been fun doing all these live streams in the past almost 3 months, right? And hopefully you guys all enjoy it so far, right? And I hope to have a chance to do this like more in the future. And again, just make sure you scan the QR code. That would be really helpful. And then that way you can also be informed if there will be any future live streams. Right. Who teaches that calculus? I believe is Wallace Stem on TikTok though, so you can check that out and you can see it. Wallace Stem, yes. Yeah, I just got a little confirmation. It's Wallace Stem. He's a great teacher. Yeah, if you guys follow his Instagram, you can see the videos that he make on Instagram as well. But again, check out the QR code right here so you can get more information. Wallace Stem will be hosting the calculus live stream on Thursday this Thursday, 4:15 to 5:15 Pacific time on TikTok. You came for 3 times in March and 3 times in April. Thank you so much. Lesson notes, Danny. Thank you so much. All right. Finally, just want to thank you to everybody who has been here for live stream, regardless however many times. Thank you guys so much. And